Hello friends, welcome to my channel Eccentric Learning. I hope you have gone through the first two parts of graphs where I have covered how we can plot the graph of linear and quadratic functions. In case if you haven't gone through those videos till now, the link has been given in the description box. Please go through it. Also, if you like my videos, then do subscribe my channel and also share with your friends. In today's video, we are going to see how we can plot the graph of equations with modulus sign. So let us start with today's video. Before seeing the graph of equations with modulus sign, first let us see what is a modulus function. Modulus function of x is defined as x when x is greater than equal to 0, and it is defined as minus x when x is less than 0. For example, mod of minus 3 can be written as minus of minus 3, which would be plus 3. Because mod of x is minus x when x is less than 0. But mod of 3 can be written directly as 3 because mod of x is x when x is greater than or equal to 0. So modulus of a number will always be a positive quantity except when the number is 0, as mod of 0 would be 0. Now, say we have been given this equation mod of x plus mod of y equal to 5, and we have to plot the graph for this equation. Well, to plot the graph for such kind of equation, it would be better to remove the modulus sign first and frame the equation and then to plot the graph, which we can do by making cases. Case 1 would be when x is greater than 0 and y is also greater than 0. In that case, mod of x would be x and mod of y would be y, and this would be equal to 5. So we are getting a linear equation x plus y equal to 5 when x is greater than 0 and y is also greater than 0. In a similar way, we can take case 2 where x is greater than 0 and y is less than 0. In that case, mod of x would be x, but mod of y would be minus y as y is less than 0. So this would be minus y and this would be equal to 5. So here, when x is greater than 0 and y is less than 0, we are getting another linear equation x minus y equal to 5. In a similar way, we can have case 3 when x is less than 0 and y is greater than 0. In that case, mod of x would be minus x and mod of y would be plus y. So we'll be getting a linear equation minus x plus y equal to 5. In a similar way, we can have case 4 where x would be less than 0 and y will also be less than 0. In that case, mod of x would be minus x and mod of y would be minus y. So this would be minus x minus y equal to 5, or x plus y equal to minus 5. Now, based on the cases, we have 4 linear equations as x plus y equal to 5, x minus y equal to 5, minus x plus y equal to 5, and x plus y equal to minus 5, which we can plot in the x and y coordinate axis. In the part 1 of the graphs video, I have already covered how we can plot the graph of linear function. So for the case 1, when x is greater than 0 and y is greater than 0, that is in the first quadrant, we have the linear equation as x plus y equal to 5. So if we plot x plus y equal to 5, we'd be getting this line where the x-intercept would be of 5 units and the y-intercept will also be of 5 units. In a similar way, for case 2, we have x greater than 0 and y less than 0, that is in the fourth quadrant. And the line here is given by x minus y equal to 5. And when we draw this line, we'd be getting this line where x-intercept would be of 5 units and y-intercept would be of minus 5 units. In a similar way, for the case 3, when x is less than 0 and y is greater than 0, that is in the second quadrant, we have the equation as minus x plus y equal to 5. So when we plot this, the line would be this line where the x-intercept would be minus 5 units and the y-intercept would be 5 units. For case 4, we have x less than 0 and y less than 0, that is in the third quadrant, and the equation here is x plus y equal to minus 5. So when we plot this line would be something like this. That is, the x-intercept is minus 5 units and the y-intercept is also minus 5 units. So this is the graph which is representing the equation mod x plus mod y equal to 5. Now, sometimes we can be asked to find the area of the region formed by these 4 lines, which in this case is a square, and area of a square is given by side square. And from the figure, we know this is the origin and this length is of 5 units and this length is also of 5 units. So the side of the square would be simply under root of 5 square plus 5 square, simply by using the Pythagoras theorem, which would be 5 root 2. So the area of the square would be simply side square, which would be 5 root 2 square, which would give us 50 square units. We can also find this area simply by finding the area of this triangle and multiplying this area by 4. So the total area of the region can also be written as 4 times the area of this triangle, which would be half into base into altitude, which would be half into 5 into 5, which will also give us 50 square units. So in this way, we can plot the graph of linear equations with modulus sign and can also find the area. Now, let us try to plot the graph for this function, y equal to mod of x plus 2 plus mod of x minus 2. So here also we have a linear equation with modulus sign and we need to plot the graph for this equation. This x plus 2 would be positive when x is greater than minus 2. And this x minus 2 would be positive when x is greater than 2. So here also, let us try to make some cases. Let us take the first case to be x less than minus 2. So when x is less than minus 2, y would be minus of x plus 2 and minus of x minus 2. As x plus 2 would be negative when x is less than minus 2 and x minus 2 will also be negative. So this will give us y equal to minus x minus 2 minus x plus 2. So this will give us the equation as y equal to minus 2x. In a similar way, if we take the case 2, when x is lying between minus 2 to 2, this would be y equal to x plus 2 minus of x minus 2. As between minus 2 to 2, x plus 2 would be positive and x minus 2 would be negative. So that's why mod of x plus 2 is opened as x plus 2 and mod of x minus 2 is opened as minus of x minus 2. So again, if we simplify this, this would be y equal to 4. In a similar way, if we take the case 3, that is when x is greater than 2, in that case, y would be x plus 2 plus x minus 2. As x plus 2 and x minus 2 both would be positive when x is greater than 2. So that's why mod of x plus 2 and mod of x minus 2 are opened as x plus 2 and x minus 2. Again, if we simplify this, this would be y equal to 2x. So when x is less than minus 2, we have the equation as y equal to minus 2x. And when x is lying between minus 2 to 2, we have the equation as y equal to 4. And when x is greater than 2, we have the equation as y equal to 2x. Now, let us try to plot the graph based on these conditions. Y equal to minus 2x would be a line which would be something like this. That is, passing through the origin and having a slope of -2. In a similar way, y equal to 2x would be a line which would be something like this, that is passing through the origin and having a slope of +2. And y equal to 4 would be a line which would be parallel to x-axis and passing through the point 0, 4. So the line would be something like this. That is parallel to x-axis and passing through the point 0, 4. But y equal to -2x is represented only for x less than -2. So for x less than -2, that is to the left side of -2, we'd be having this graph. And between -2 to 2, we have y equal to 4. So from -2 to 2, we'd be having this graph, that is the line y equal to 4. And when x is greater than 2, we have the line as y equal to 2x. So when x is greater than 2, that is on the right side of this 2, in that case, we'd be having this graph. So this green color graph would be representing the graph for this equation. So in this way, by making the cases, we can plot the graph for such kind of equations. Now, let us try to plot the graph for this equation. I'll be showing you two ways of plotting the graph for such kind of equations. The first is by making cases, and the second one is by going step by step. First, let us see how we can plot the graph simply by taking some cases. We know 2 minus x would be positive when x is less than 2, and 2 minus x would be negative when x is greater than 2. So let us make two cases. Case 1, when x is less than 2, and case 2, when x is greater than 2. So when x is less than 2, in that case, this would be y equal to 4 minus of 2 minus x, because 2 minus x would be positive when x is less than 2. And this would give us y equal to x plus 2. In a similar way, when x is greater than 2, 2 minus x would be negative. So this would be y equal to 4 plus of 2 minus x. And this would be y equal to minus x plus 6. Now, let us try to plot the graph of this equation by using these two cases. So when x is less than 2, we have y equal to x plus 2. And when x is greater than 2, we have y equal to minus x plus 6. Let us put the point 2 to be somewhere here. Now, when we plot the line y equal to x plus 2, this would be something like this. And when we plot y equal to minus x plus 6, the line would be this line. But for x less than 2, this equation is represented by the line y equal to x plus 2. So for values of x less than 2, this line would be representing this equation. And for x greater than 2, this equation is represented by y equal to minus x plus 6. So for values x greater than 2, this line would be representing this equation. So this blue color graph represents the graph for this equation. Also, at x equal to 2, we can find the value of y by using either of these lines, as both these lines will give us the same value of y, which would be y equal to 2 plus 2 or y equal to minus 2 plus 6, that is 4. Now, let us see one more way of plotting the graph for such kind of equations simply by going step by step. First, let us draw the graph of y equal to 2 minus x. Then we'd be drawing the graph for y equal to mod of 2 minus x. Then in step 3, we'd be drawing the graph for y equal to minus mod of 2 minus x. And then finally in the step 4, we'd be drawing the graph for y equal to 4 minus mod of 2 minus x. Now, when we'd be plotting the graph for y equal to 2 minus x, this would be a line which would be having x and y intercept as 2 and 2 units. In the step 2, when y is equal to mod of 2 minus x, in that case, all the negative values of y in y equal to 2 minus x will now become positive. So the graph for y equal to mod of 2 minus x would be something like this. That is, all these negative values has now become positive when y is equal to mod of 2 minus x. And this point will be 2. In step 3, when y is equal to minus mod of 2 minus x, in that case, all the positive values of y in mod of 2 minus x will now become negative. So the graph of y equal to minus mod of 2 minus x will now be something like this. That is, all the positive values has now become negative because of this minus sign before the modulus. And this point will again be 2. Now, in step 4, when we are adding plus 4, in that case, all the values of y in step 3 will be increased by 4 units. So that means the graph in step 3 will now be shifted upwards by 4 units, which will give us this graph. So if we go step by step as well, we'd be getting the same graph. So to plot the graph for such kind of equations, either we can make the cases in this way or we can go step by step in this way. Now let us use step-by-step method in plotting the graph for this quadratic equation inside a modulus sign. Well, how we can plot the graph of a quadratic equation inside a modulus sign, I have already covered in part 2 of the graphs video. So I would suggest you all to go through that video first and then to come back to this video, the link of which I have given above and also in the description box. So if we go step by step, in that case, the step 1 would be to draw the graph for y equal to x square minus 4. The step 2 would be to draw the graph of y equal to mod of x square minus 4. And finally, the step 3 would be to draw the graph of y equal to minus mod of x square minus 4. So first, let us try to draw the graph of x square minus 4. We know this is a quadratic equation and here the leading coefficient is positive. So the curve would be an upward parabola and we can find its root simply by equating this part to be 0. So when x square minus 4 is 0, in that case, the two roots would be plus 2 and minus 2, that is plus minus 2. So we need to draw a parabola whose two roots are minus 2 and plus 2, and it is an upward parabola. So if we draw the graph would be something like this. That is, the graph is attaining its minimum value of minus 4 at x equal to 0 and having the x-intercepts at plus 2 and minus 2. Now, let us plot the graph for y equal to mod of x square minus 4. Since this graph represents the graph for y equal to x square minus 4 and from x equal to minus 2 to plus 2, we have some negative values of y, but due to this mod sign in step 2, all the negative values of y will become positive. So the graph of y equal to mod of x square minus 4 would be something like this. That is, all the negative values now has become positive because of this modulus sign. Now, if we come to step 3, we have a negative sign before the modulus sign. So all the positive values in step 2 will now become negative. So the graph of y equal to minus mod of x square minus 4 would be something like this. That is, all the positive values here has now become negative. So this graph represents the graph of y equal to minus mod of x square minus 4. So in this way, we can go step by step to plot the graph of such kind of quadratic functions. So That's it for today's video, in which we have seen how we can plot the graph of equations with modulus sign. And in the next video, we are going to see the graph of higher order polynomials. I hope you have learned something in today's video, but if you have any confusion, you can watch the video again, and still if you have any doubts, you can put it in the comment box. I will try to answer each one of your queries. So if you like my videos, then do subscribe my channel and also share with your friends. I will see you all in my next video. Till then, keep learning, keep sharing, and keep growing. Thank you.